Hello everyone, how are you? So today what we are going to do, let me share my screen first. Right. So today we are going to have one excited session with us where we are going to understand about the fundamentals of electrical and electronic design. So basically all of you gone through a lot of things in day-to-day life also. Maybe you are into the field of electrical and electronics also, but here in this particular short way we will understand the concepts, or you can say just fundamental, that are required to understand the electrical and electronic design. So let's start this particular topic and check very first thing, that is basic concepts. So electricity, all of you know what is electricity. We all have the electricity in our home, in our workplace, everywhere. But what it is? Basically, it is a flow of current. Electronic, electrons, along with electronics, we have the electrons. You all heard about it in your schools, in your college, in your studies. So that particular flow of electrons that we see the current, due to the potential difference, that is the voltage between the 2 points. So technically it is the flow of electrons that gives you the electricity, and the potential difference that happens in between the 2 points, which is voltage. So what is the key quantities in it? The terms that we have. First thing, that is voltage. Second thing, that is the current. Third is the resistance. And the last is the power. So all together are working to give you that electricity. So the abbreviations are also along with it, which is the voltage, current, resistance, and power. V, I, R, and P, as you all can see over here at this point, right? So combined, there is a law everywhere, in physics, in electrical, electronics, in every field, in mathematics also. There are a certain law created for these kind of logics. Here, for electricity, we have the Ohm's law that says V, that is the voltage. That is what is voltage? That is the product of the current, okay, and the resistance that is in that particular wire, okay. So that is the Ohm's law, right? And third thing, you all heard about the two type of different current flows, that is AC and DC, right? AC and DC, the difference, that is direct current flow in one direction only, that is a DC, okay, that flows only in one direction, right? And what is alternating current? That changes its polarity periodically. Like, see, if you will say DC flows like this, okay, whereas AC, as we says, changes polarity. It means it flows like this, positive, negative, like this. So that is the basic concepts of electrical. Fine. Let's check few of the components, right? Maybe you've seen these components also. Very first is the resistor, okay. So see the relativities, okay, the connection in between uh, these components and the current law. Resistor controls or limit the current, right? The current that is flowing, how you will control it? If there is nothing to control, it will be infinity, right? So we need something to control over it. That happens using resistor. Then we have the capacitor that stores this energy, okay, which smooths the voltage. Fine. Third is the indicator, okay. Indicator is what? Or inductor, you say, right? It indicates something. What it indicates by the name inductor, it stores energy. That is the electrical energy the capacitor is also saving, right? But what inductor do? Inductor stores energy in magnetic field, okay, that opposes change in current. Fine. So the next thing that is, we have the transformer. All you see in this one, correct? So what is the role of transformer? Steps the voltage that we are getting up and down as per the requirement. That is the thumb rule. As per the requirement, we do all the things, right? So whenever we require the higher voltages, right, and sometime we need to make it down also, correct? So we use transformer for that purpose. Switches and fuses that controls and protect the circuit from a lot of different kind of things, like we switch off our light or switch off our bulb, correct? Switch off our fan, correct? The fuse that helps us whenever the error, okay, or any fault comes over there, it got disconnect the supply, correct? So these are the few of the components, okay? So just to put into your imaginations, right, that these are the few components that you will see in electrical field very frequently, right? Just like ABCD in alphabets, whenever we need to learn English, the very first thing is to learn ABCD, right? In the same way, we need to understand these components of electrical first of all. Fine. Then electronics. So relative, both are relative, correct? For the trending market, or you can say the trending technology, both things we need to understand. So what are the different electronic components we have? Diode, transistor, op-amp, ICs, right? Few of them you heard about it, like IC, integrated circuit, you heard about it. But if you will look into the diode, that allows the current in one direction only. Remember the last slide? Over there also we have something like this. Okay, fine. So transistor, it amplifies the signal and works as a switch. So see the relativity in between the electronic and the electrical components. Fine. And the difference is electrical component works on the higher level, okay, whereas electronic component works on the smaller scales. Fine. Op-amp performs mathematical operations like amplification if you want to filtering the things, right? So whenever you have the circuit, electricity and different signals with you, how you will manage it? If you want to divide the signals into two parts, how you will do, right? Definitely we will use mathematical functions like divide, right? But how? So op-amp works that time. IC, compact thing, okay, just like micros, okay. So if you want that a big circuit will be summarized or compacted into a small chip, that is ICs, okay. So these are the quick components that you will hear or you will work with it, or with these terminologies you will go through in day-to-day working. Fine. So check about the circuit design principle, correct? This is our major part that we are going to have into it, that is designing. All these things are there, like electricity is there, different circuit boards are there, electronics is working on it to design new technologies. But how to design it? What is the concept behind it, right? Randomly we can't place the components on a circuit board and start working. There must be some law, there must be some principles on which we need to work. correct? So the very first thing that comes over here, let me put it here, that is series and parallel circuits. So different scenario, you all understand about the series and parallel things, but the circuits that we are designing that distributes the flow or the current or the voltage into two type of circuits, that is series and parallel circuits. Okay, either you want to distribute voltage or current, you need to use series and parallel operations for it. And for that one, a law, again, as I said, every time we have some laws that are working behind it. The law is Kirchhoff's law. First is voltage law, second is current law. Just two things are there, voltage and current. So definitely to design any circuit, we need to work on, or we need to follow the principle of voltage and current, right? That where the voltage law says it is sum of voltages around the loop will need to be equals to zero. Whereas current, sum of currents at a particular nodes must be equals to zero. Then only your circuit will work. Fine. And one more component that we already seen in the last slides, that is the power. What is power? Power is nothing, just the product of voltage and current. Got it? So likewise, there are certain laws and certain working principles also. So we need to look into these particular design aspects to understand how to design these circuits. Fine. So if you want to design any circuit or design any particular ICs or a particular system, you need to consider few major things into it. First is safety. You are dealing with current, voltages, power, right? The electricity. So the safety first. Follow this thing. That is, in safety, what you need to do? The grounding, the insulations. You need to put the circuit breakers also into it. Okay, and efficiency. Nowadays, the era is to give maximum efficiency in different type of things. So minimize the power losses, right? Resistance, the heat release, you need to manage that thing. So the efficiency of your system will be more. Reliability. If your system or your design is not reliable, it will not get success in the market. Okay, or even it will not work properly. So correct component rating and tolerance checks need to be done with it. Fine. The last, not the least, the sustainability. Energy efficient devices you need to use. Fine. Renewable sources integration, if it will be there. As you all know, the solar is getting very trending in this era of energy generation, right? So definitely the renewable energy sources need to be integrated with it, so that in the absence of generation, the power will be getting maintained into it, right? Definitely that thing comes into your mind now, that what is the application of both these things, right? If you are in this particular domain of electrical and electronics, you very well know the applications. But if you are very new to these terminologies, you must know that the electrical designs are used into power supplies, into the motors that you are using, right? Lighting, definitely. And the grids that are created to supply all these electricities. And in electronics, right now, most probably you all are using laptops. So definitely the computers are designed by these electronic design principles. The sensors that you are using into your car, bikes, two-wheelers, and everything over there. The sensors are working with it. Okay. In communication system in your mobiles, definitely it is all created just due to the advanced technologies of electronic designs. Automations are working with it. So as you can see into it, that the combination of these two designs or these two domains together, they are giving you the latest technology that you are right now using in day-to-day life. Okay, so go through it, understand what you are feeling through these latest technologies. Okay, how these are created, what is the design aspects behind it, and the smart functionality, right? If you see the advancement in the technology nowadays, there are a lot of things, just like in laptops, in mobiles, you can see over there, even in the mobile chargers, you can see there are drastic changes into it, right? So technology depends on the design perspectives, right? And from where it is coming? From electrical and electronic designs. Okay, so this is what we have in this particular small video. So you can need to understand these two aspects in detail. We are going to go over there. Okay, that's it. Thank you. Thank you so much, all of you, for your patience to hear it. Thank you. Most welcome, all of you.